There we go. Okay, so we're going to do the lesson on combinations today. So we are past that. We are here. Combinations. You know how sometimes the English language, we don't use words properly? A good example is theory. Oh, it's only a theory. Man, does that make us science types cringe. Theories are very certain things, right? Newton's gravitational theory, we're darn sure that that's a correct thing. Almost nothing we've ever just let go of that is heavier than air has floated away on us. So we're pretty sure gravity's solid. We can predict eclipses. We can predict where comets are going to be to the nearest millimeter a million years from now. We've got this stuff. Well, this is a solid theory, but people use the word "it's only a theory." When people say conspiracy theory, that drives me insane. I don't say that anymore. You know what I call them now? From now on, they are conspiracy fantasies. That's the way we should change the language. There is no credence to the nonsense that that the Earth is flat, the election was stolen, all of those things. Those are conspiracy fantasies. So here's another one for you. What do you call that thing that you close every day on your locker? No, not the door. I mean the little thing with the numbers on it. Don't you call it a combination lock? It isn't a combination lock. It's a permutation lock. You know why? Well, let's say that your combination was 5, 10, 20. Could you put in 20, 10, 5 and get your locker to open? No, because the order matters. Guess what? When order matters, it's a permutation. Anytime somebody gives you a bunch of numbers, they'll say, oh, this is a combination of numbers. Whoa, 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 whoa. Don't use the word combination that way. If the order of those numbers matters, it's a permutation of numbers. But we don't say that. Just like we don't say conspiracy fantasy. We throw the word theory at it. Theory is a great word. It's got a specific meaning. Anyway, combinations, underlined and bolded here, where order doesn't matter. If the order of the numbers doesn't matter for how many things I'm counting, then that's not a permutation anymore, it's a combination. Question? Yeah, of course. Okay, so, bloop. Example. Form a group of 3 students from A, B, C, and D. Now the combinations are ABC, ADB, ACD, BCD. Notice that ABC is the same as ACB. It's the same 3 people. Alvin, Charlie, and Brent. Brent, Charlie, and I forgot what I said for the A was. But anyway, it's the same 3 people over and over again. Those permutations are all the same combination or group. So we need a new formula. The permutation formula just tells you how many arrangements there are. But how many of those arrangements are the same 3 things? Well, the combination formula is the permutation formula divided by how many items you've taken factorial. So here's the way the formula actually works. And yes, this formula is on your formula sheet. You don't have to memorize it. That's the combination formula. And this one has a shortcut. Sometimes we write it in a bracket like this. Because, to be honest, this one's far more common in mathematics and combinatorials. Because most of the time, what are we using combinatorials for? We're using it usually, the most common place we use combinatorials, which is permutations and combinations together. Altogether, we call this combinatorial map. The most common place we use it is when we're talking about statistics, counting people, usually. And again, if I choose 3 people at random, it doesn't matter what order I chose them, it's the same 3 people. Okay? So for example, there are 14 females and 8 males in a math class. You want to form a group of 5. How many groups can be formed? Okay, so you know what? You have different page numbers than me, right? We've had this conversation yesterday. So I'm going to I better go to my notes here and make sure that nothing's changed when the page numbers change. And I want to make sure I don't goof up the answers. Okay, so how many groups can be formed? So I am choosing 5 out of 22 things. So that's 22 things. And I'm choosing 5 of them. It's kind of cool. The C stands for the word combination, but the nickname we've kind of gotten for that is choose. So most math types would say that's 22, choose 5. Or how many ways can you choose 5 out of 22 things? And that, using the formula, So let's look at the formula. The formula is n factorial, so that's 22 factorial, over 22 minus 5 factorial, 5 factorial. And of course, there's nothing between those, so that's a times. I should probably put this down so I can write better. There we go. And on my calculator, I can run this two ways. I can run this exactly the way it looks, which is 22, what's factorial on this thing? Shift 4 on this calculator that's in my hand, divided by, open a bracket. I guess I would do this subtract in my head rather than punch that as an extra bracket. So that's 17 factorial times 5 factorial. So 17 factorial times 5 factorial. Then close my brackets. Oops, I just goofed that up. Close my bracket and hit equals. And I get 26,334. Pretty much all of you could do this a shorter way. Most of you do have a button, you might have to look for it, that is N choose R. Some of you have a permutation button too. But not every scientific calculator has a permutation button. They all have a combination button. On the one I'm holding, and I'm holding a Sharp EL53. Oh, I used to know where it was. It's a shift somewhere. There it is, it's shift 5. Oh, and it has the permutation on shift 6. So you want to try your own button? Try it. If you're rocking the TI-30X, the old school one, oops. It is, oh, it's here somewhere. There we go. Shift 8 is the combination, and shift 9 is the permutation. I didn't think this one had a permutation. It does. The older versions of this didn't have permutations. Anybody got a calculator brand I haven't mentioned here? That was the Sharp, that was the TI. Anybody rocking a Casio? Casio has put theirs possibly on a, nope, it's its own button on the Casio FX300. It's in the top left corner, kind of. N choose R, NCR. And if you're rocking a fancier Casio, the Casio FX300 Plus, the one where it gives you a rational button, like a number over a number button, it might be a menu on this guy. Anybody rocking one of these? I don't know, I give up. I can't find it. Sometimes it's a menu. If anybody's using their graphing calculator, you have to go to Math, and then go over to Probability, I think. Yep, because this stuff gets used a lot in probability, so it's in the probability menu. Okay? All right, guys at home, if anybody's got a calculator and you absolutely can't find that button, let me know, and I'll see if I can help you out. But give it a try. Try this button, you should get this same number without having to punch all of that. Didn't work? You punch it in, I think, the order that it says. So you would punch in 22, that button 5. Let me try it with yours. You're using this guy, right? Yeah. 22, shift 8, 5, hit equals. Yep. So that saves a lot of work. It's a handy button. Don't rely on this button too much, though, because you do have to be able to use this formula, because sometimes we do some algebra where you can't use the button, as you'll see in a minute. Anyway, let's try this again now. How many groups can be formed with 2 females and 3 males? Now again, do I care which 2 females? Do I care which order I pick them? No. So I have to do it as 2 calculations. The females and the males. So the females, there's 14 of them, and I'm choosing 2. And then for the males, there's 8 of them, and I'm choosing 3. I think this time I am definitely going to go with my calculator. So let's give that a try with the calculator. 14, choose 2, times 8, choose 3, and I get 5,096. Yes, I could get that by the long way. I might even be able to do some simplifying and do it without my calculator, but I'm not going to go through that right now. How many groups can be made with Joseph, 1 other male, and 3 females? Okay, Joseph, there's only one way to choose Joseph. So Joseph, 1. 1 times, and then this next one, so this is the Joseph. 1. Then I'm going to choose one other male. Other male. And then I'm going to choose 3 females. Okay. Next. How do I choose the other male? Well, wait a minute. I only get to choose 1, but how many are left once I've picked Joseph? 7. So it's 7, choose 1. 3 females? Well, there's 14 to choose from, and I'm picking 3. Now, what do you think 7, choose 1 is? Let's explore 7, choose 1. According to the formula, that's 7 factorial over 7 minus 1 factorial times 1 factorial. Well, 1 factorial doesn't mean much. And 7 factorial over 6 factorial should be easy for you to do in your head. What do you think? What's 7 factorial over 6 factorial? It's just 7, because this is 7 times 6 factorial, and then it's just 7. And that's actually a true statement. X choose 1 is equal to X, logically. So that's a true statement. Write that down. Don't bother punching that ever. It's a waste of buttons. And then while we're at it, what should X choose X always be? Shouldn't it be 1? If the order I choose them doesn't matter, quick, I have to, out of this class, make a committee of 3 people, and there's only 3 people in the class. Isn't there only one way to choose that? Let's look at the algebra. X choose X would be X factorial over X minus X factorial X factorial. Well, those things are just 1. And the other thing is 0 factorial, and we have talked about this already. 0 factorial is 1. So, yep. So these are 2 facts that you can use to solve anything where it pops up without having to punch extra buttons. So back in the problem we were looking at, come here problem we were looking at, there we go. That's really just 1 times 7, which I'm just going to say is 7, times 14, choose 3. That I'll now run through my calculator. 7 times 14, choose 3, 2548. There are 2,548 ways to make a group with Joseph, another guy, and 3 girls. Okay? All right. There's a your turn. There's always a your turn, isn't there? Okay, want to give that a try? For my actual video, I'll pause the video. So give this a try. Pause the video here and see how it goes. Okay, we're back. How many ways can a store manager hire for 3 identical positions if there's 12 candidates? Pretty simple. 12, choose 3. I actually don't need a calculator for this one, right? That's using the formula 12 factorial over 12 minus 3 factorial, 3 factorial. So that's 12 factorial over 9 factorial, 3 factorial, which is 12 times 11 times 10 times 9 factorial over 9 factorial. And I know 3 factorial is 3 times 2 times 1, which is 6. So those cancel. 6 goes into 12 twice. 22 times 10 is 220. If you ran it through your calculator, hopefully you got the same answer I did. Okay, number 2. This one I think I'm going to need a calculator for. The chess club has 9 grade 10s, 5 grade 11s, 14 grade 12s, and 2 kids from each grade has to make up the team. So 9 choose 2 gets me my grade 9 students, or my grade 10 student, I should say. 5 choose 2 gets me my grade 11 students, and 14 choose 2 gets me my grade 12 students. Okay, and this is not something I'm going to easily do without a calculator. If I absolutely had to do without a calculator, I could try, but I think I'd just run that through my calculator. So try it. You should get 32,760. If that doesn't work for you when you punch buttons later, you could come up to me and I can give you a little one-to-one tutorial on how to work your calculator. Okay? If there is anybody here who is just doesn't have a choose button on their calculator, well, as long as you have a factorial button, you could write this out the long way. It's 9 factorial over 9 minus 2, 7 factorial, times 2 factorial, times 5 factorial over 3 factorial, 2 factorial, times 14 factorial over 12 factorial, 2 factorial. And then this would be 9 times 8 over 2, 5 times 4 over 2, and 14 times 13 over 2. 2 times 2 times 2 is 8. That makes life a little easier. But I don't think without a calculator I can do 9 times 20 times 14 times 13. But run that through the calculator, it should be the same answer as that. That's what I would do if I didn't have this choose button on my calculator. If I didn't have a combination function on my calculator, this would be my work right here. Okay? And I'm pretty good with numbers, so I can do that stuff very quickly. So if you're not, hopefully you've got the right button on your calculator. Is there anybody who hasn't, guys at home too, who hasn't been able to find the NCR button on your calculator? What kind of calculator are you using? It's a Sharp. So Sharp like this guy? Okay, then let's see. One of those. Ah, that one might not. Okay, we'll look later. But it does have a factorial though, right? Okay, so then you can do it this way for now. But a little later, I'll see if I can help you with that calculator. Okay, let's move on to algebra. Right? Just like permutations, you can do algebra with combinations. First example here is, can you simplify n choose 5 over n minus 1 choose 3? All right, well, that would be, I'm gonna have to write small here. This is gonna take up a lot of room. That's gonna be n factorial over n minus 5 factorial times 5 factorial divided by n minus 1 factorial all over n minus 1 minus 3 factorial, 3 factorial. Okay, I'm going to do two moves at once here. Move number one. Move number one, I might as well simplify that. What's n minus 1 minus 3? It's n minus 4, right? Move number two, what happens in fraction land when you do a divide? You multiply by the reciprocal, right? That's excellent. So it's going to be the numerator and denominator of the first one. And instead of divide, times the denominator, and remember I made that n minus 4, over the numerator of the thing I was dividing by. Right? So does everybody get that I just did two steps there? I simplified that bracket on the bottom and I changed divide to times the reciprocal. Now I use my knowledge of how factorial works. N factorial is n times n minus 1 factorial. And I'm going to stop there. Why did I stop there? I could keep going, but I actually see that down here I have an n minus 1 factorial. Bye-bye. I'm going to down here change this to 5 times 4 times 3 factorial. And then I'm going to stop there. How come? Because there's a 3 factorial on the top. Bye-bye. N minus 4 factorial is like saying n minus 4 times n minus 5 factorial. And I stopped. Why did I stop? Because down here I have an n minus 5 factorial. Bye-bye. Isn't that nice? Look at all the cancels that happen. I have an n times n minus 4 on top, and all that's left on the bottom, I think, is a 20. Right? Oh, wait a minute. Do I have an n minus 4 on top? Yeah, I guess I do, right? Yeah, I have an n minus 4 on top, and I have a 20 on the bottom. And that's it. I guess I could multiply that out and say it's n squared minus 4n, but I'm happy with that as an answer. That's about as simple as I can make that. I could say or n squared minus 4n over 20. Okay? All right, let's try this one. 2 times, okay, n choose 2 is n factorial over n minus 2 factorial, 2 factorial. N plus 1 factorial over n plus 1 minus 3 factorial, 3 factorial. Okay. What can we do with this stuff? Well, you know what? How about just to make life easier, 2 divided by 2 is 1. Remember, 2 factorial is just 2 times 1. That's just 2. Now, I think before I expand any of my factorials, I'm going to simplify the one on the right. And then form a strategy here. So this is n minus 2 factorial. Oh, and there's still a 3 factorial kicking around. Okay, what am I going to do with that? Well, I think I'll expand the top to n times n minus 1 times n minus 2 factorial. That cancels the bottom. Isn't that nice? Bye-bye. Over on this side, this is n plus 1 times n minus 1 times n minus 2 times n minus 3 times n minus 4, so I'll just slap a factorial on that. That cancels the n minus 2 factorial on the bottom. Still stuck with the 3 factorial though. Now I'm going to divide both sides of the equation by n. Going to divide both sides of the equation by n minus 1. And I have 1 equals n plus 1 over 3 factorial. Okay, 3 factorial is 3 times 2 times 1. That's 6. So 6, I'm going to times both sides of the equation by 6. Minus 1 from both sides of the equation. And n is equal to 5. Question. Oh, what happened? Why can I see it and you can't? This is weirdness. Okay, I have a projector issue going on, and I'm going to have to figure out how to solve it. Okay, so hold on. Very, very strange things are happening. I'm going to go to this. Yeah, a network error occurred. Well, oh, that probably stopped my video too. Yep. Oh, no, we're recording. No, we're still, the recording's still going. That's good news. But okay, so I'm going to have to try to fix my network error. Okay, oh, not found. None of the projectors are found. We have a network outage issue. So what can I do here? Let's try just shutting it off and turning it back on. So I'm going to close that. Close. Okay, good, close that. Okay, let's see if we turn it back on again, what happens. Okay. Okay, I'm going to pause the recording until I fix what's going on. Okay, I'm unable to fix the Wi-Fi connection problems from this laptop to anything, so I'm going to have to switch to my desktop computer to try to finish this off. So I'm going to end the video here and then make a part 2 video in a little bit.